Next, we are going to discuss demodulation of FM signals. There are two methods for the detection of FM wave. First is frequency discriminator and second is phase lock loop. In frequency discriminator, there is both slope as well as envelope detection. And the phase lock loop is the indirect method for the generation of FM wave, and it is a widely used method. So first we talk about frequency discriminator. Frequency discriminator is a type of FM demodulator that produces an output voltage linearly dependent on input frequency. Frequency discriminator consists of slope detector, that is a type of differentiator, and followed by envelope detection. So in frequency discriminator there is both slope detection as well as envelope detection. In the first stage we use slope detection technique by using a simple tuned circuit. This circuit is tuned slightly above or below resonant frequency F0 over a limited range. Input of the differentiator is FM wave, denoted by equation St equals to AC cos within bracket 2 pi FCT plus 2 pi KF integration m tau d tau. After passing through differentiator, we get d upon dt of St, which is simply the differentiation of FM wave. So, d upon dt of S function of t equals to minus sign within bracket 2 pi FCT plus 2 pi KF integration m tau d tau into 2 pi FC plus 2 pi KF into mt. This is simply a differentiation of FM wave. Now after arrangement we get d upon dt into St equals to minus 2 pi AC within bracket FC plus KF into mt into sine 2 pi FCT plus 2 pi KF integration m tau d tau. Here the first expression is called envelope, which represent amplitude modulation, and the second represent frequency modulation. So here we have both amplitude and frequency modulated terms. Or we can say that the output of differentiator having both amplitude and frequency modulated terms. Now we note a point. For a proper tuned circuit, the carrier frequency of the incoming FM signal must be less than resonant frequency of the tuned circuit. So here we assume that the carrier frequency is less than resonant frequency. The circuit diagram of tuned circuit with resonant frequency F0 is shown in figure. It consists of resistance, inductance, capacitance combination with L and C are connected in shunt. This tuned circuit having a transfer function H function of F. The input is FM signal denoted by ST, and the output of this circuit is S suffix C function of T. The amplitude response of the tuned circuit is denoted by mod of HF and shown in first figure. This circuit is tuned slightly above or below the resonant frequency F0. So we get this type of amplitude response having positive slope and negative slope, and here the FM signal with carrier frequency FC must be less than the resonant frequency F0. So FC is less than F0 for proper tuned circuit. And the main function of tuned circuit is to convert frequency variation in case of FM into amplitude variation. As we know that in FM signal there is instantaneous frequency that swing above or below the carrier frequency. The amplitude ratio of this tuned circuit convert the frequency variation into amplitude variation and resulting the output signal S suffix C function of T. This is explained more clearly with the help of waveform. First figure is the amplitude response of tuned circuit with carrier frequency of FM below the resonant frequency F0. Second figure is FM wave having frequency variations, that is instantaneous frequency varies above or below carrier frequency with the relation instantaneous frequency equals to Fc plus Kf into Mt. Now using the amplitude ratio from the characteristic of tuned circuit, the frequency variations get converted into amplitude variation and generates an envelope. So the output of tuned circuit is S suffix C, that is in the form of an envelope with amplitude variations. As shown in figure, this output signal having both amplitude as well as frequency modulated characteristics. But here we extract only the amplitude variations using envelope detector. And after passing through envelope detector, that is the second stage of frequency discriminator, we get demodulated signal. This demodulated signal corresponds to the massive signal denoted by S suffix D. In this method of FM demodulation, we extract only the amplitude variation by discriminate the frequency, hence called frequency discrimination method. Here in envelope detector there is DC blocking. Now we note a point. In frequency discrimination method, we use slope detection technique that having two basic problems. First problem is unexpectable amplitude variation of input FM wave, and the second problem is the range of the linear slope is quite small. And in order to avoid these problems, a limiter followed by balanced frequency discriminator is used before envelope detector. Here, limiter is a nonlinear device that reduces the amplitude variations, while the balanced frequency discriminator extends the range of linearity of slope detector. This modified circuit is shown in figure. In this, there are three tuned circuits. First, at the input side of the transformer, that is tuned to carrier frequency, and the other are at the output of the transformer. At the secondary side of the transformer, the upper tuned circuit is called positive slope circuit and is tuned above carrier frequency, while the lower tuned circuit is called negative slope circuit and tuned below carrier frequency. And because of this tuning arrangement, we call it balanced frequency discriminator. The output of the tuned circuit on the secondary side are detected separately using envelope detector. And the difference of these two envelope detected output is proportional to the message signal. So on the basis of operating principle, as the instantaneous frequency of FM wave changes, there corresponds an amplitude variations in opposite direction with the help of secondary tuned circuit called positive and negative slope circuit. And the difference of these amplitude variations is known as S curve. This curve is a frequency versus voltage characteristic and the shape is like letter S, hence called S curve. That is shown in figure. Here the dotted line is the amplitude response of the tuned circuit, upper for positive slope circuit and lower for negative slope circuit. And the difference of the two envelope detected output is shown by the solid line, which is proportional to the message signal. On this S curve, we have some observations. The resultant curve, that is the difference of the two envelope detector output, having a linear frequency response with width of about 3b. Here for our convenience, we mark frequency scale Fc, Fc plus 2b, Fc plus 4b for positive scale and Fc minus 2b, Fc minus 4b for negative scale. And correspond to this scale, there is a linear characteristic having a width of 3b. And we know that in the case of wideband FM, the transmission bandwidth is twice of delta F. So twice of delta F is equals to 3B. So the frequency deviation delta F for this linear curve is 1.5B and gives a satisfactory output. But beyond frequency deviation of 1.5B, there is a nonlinear characteristic, and this results a distortion. So we can say that the operation of this detector is limited and gives output to a small deviation only, that is delta F equals to 1.5B. Next, we discuss some more frequency discriminator. Practically, there are many frequency discriminator. First is ratio detector. This is another type of balance modulator, but it is widely used in the past as it provides better protection against carrier amplitude variations. For past many years, these ratio detectors were used in almost all FM receivers as a standard. Second is zero crossing detector. These are based on digital integrated technology and basically a frequency counters that measures the instantaneous frequency by counting the number of zero crossings. Or we can say that instantaneous frequency is measured by rate of zero crossings.